Missed about 2 minutes of the class, but all I've done so far is talk about these data types up here. I'm now talking about jit.world. So jit.world creates what's called an OpenGL context, which is any 3D object that you're going to render on your screen lives in a universe that's defined by this language called OpenGL, which is a graphics language that video cards understand and use to render things on the screen a lot faster than your CPU can render, right? So everything that you're going to render on the screen has to reside in an OpenGL context. If you don't give your jit.world a name, they give you an OpenGL context for you, and this is the name of it, U124003213, or something like that, gibberish. That doesn't matter. It's fine. Like, if you don't care, it doesn't matter. Everything should work anyway. But if you have more than one jit.world that's trying to render to the same context, that's when you have problems, right? So if you don't give it a context, I think you're fine. If you make another jit.world, you're probably still fine because they have independent names. This one's U400397, and this one's U124003213. But the better way to do it is to give it an actual context. My world. Make sure you're not putting spaces in the name of your context, because Jitter doesn't like spaces. It will interpret a space as two separate arguments instead of one argument, right? So now it creates an OpenGL context called my world. Now, if you had another patch open and it also said jit.world my world, you would have problems. You would have errors. You would see, if things weren't working right, you can check your Max window, Command M, and it will show you any errors you have. I was trying to figure out how the mouse worked earlier, and I was trying to send it getMouse, and it says it doesn't understand getMouse, right? So that's an example of an error that might be thrown. So if you had a problem with your OpenGL context, you might have an error that says invalid context. Okay. So integers obviously don't have any floating point values, no decimals. The floating points can have decimal values, right? These two data types are interchangeable in that if I pass go ahead and make a new integer object, integer number box by hitting the I key. If I pass a float into the integer, it will still pass the value, but you see it trims off everything after the decimal point, and it doesn't round. So 5.1 is 5, 5.89 is 5, right? But 6.1 is 6, so it won't turn to 7 until it gets to 7, right? So it's ignoring everything to the right of the decimal point. Yes?
I just have a question.
Yes?
I had some weird issues with the program not making specific boxes, and also not being able to do anything with the integer or the float boxes either.
So how are you making an object? Are you just double clicking? Are you hitting N? What are you doing?
I'm double clicking.
So double clicking.
I.
Okay, so that is a different object.
Oh.
Because that is an int object. What you want is the shortcut I. Instead of double clicking, just hit I.
Oh, okay.
If you went and you did the double click route and you wanted to spawn this number box, it would actually be called number is the name of the object. This actually is an interesting segue to the difference between graphical and non-graphical objects in Max. There are two I mean, there are two types of your visual objects. In Max, there are graphical user interface objects, and there are objects that don't have a graphical user interface. This number box is a graphical object. Obviously, it shows me the value that's in this integer, and I can interface with that with my mouse or my keyboard, right? I can also store that in what's called an int box, which is either a new object that with an I in it, or you can say a new object with the word int in it. Those are the same object. This is like the old name of it, and this is like the new name of it. This is the same. I mean, this is a non-graphical object. It can also store values. So if I patch this to the right inlet of this int, as I move this around, it actually stores whatever the last value that came into it was. And then if I send a bang to it by hitting a B to get a button, and then patching that to the thing, and then displaying that value either with a message or another int box. So if I'm going to pass it to a message, I'm going to pass it to the right inlet of the message so it actually displays it. Now if I send a bang to this, it'll reveal what was stored in that box. But it doesn't show you because it's a non-graphical object. Does that make sense? I'll take your silence as assent. All right. Yes.
So the integer box, the one that has the letter I in it, that's you hit this N to
get a new object. There's a couple different ways. You can double click on the canvas on the patcher. You can hit N, or you can up here. There's a new object icon you can click.
But the function of that object, as opposed to just having, so that just stores.
It's for storing an integer. So usually it's used to, like, I want to retrieve the last. There's like a string of numbers coming in, and then it's going to stop, and I want to store whichever the last one was. So like I can have this number string is going up and down like this, and maybe I don't know where it ended up. I can hit the bang, and it'll bang out whatever the last number was that was stored in there, right? You can use it other ways too, but that's the main way that I use it. Okay. All right, so like I said, so floats can be converted into ints with no problem. It just strips off the decimal point. Ints obviously can go into floats. It's just not going to have anything after a decimal point. Those are interchangeables. Some data types are not interchangeable. If I try to send this list to a float object, it's not going to do anything. And in fact, it throws an error and says, number doesn't understand the word this. So, right? So those are incompatible data types. So let's see. Metro. That was one we didn't look at, but some of you discovered in your homework. Metro creates bangs on a schedule. I mean, on like a metronome, and it has an argument of the interval, which is how many milliseconds you want between bangs. If that's inconvenient for you and you'd rather have a hertz, you can use hertz also. So I could say I want 30 bangs a second, I can say 30 hertz, and it understands that. I use hertz more often than I use milliseconds. But like Metro 33, I believe, would be the same as 30 hertz, right? Metro 30, I don't know. What?
That X object that you probably.
This is a toggle. You hit T to get it. Okay. So if I have the toggle, the Metro, and now I put a button underneath this, and I turn it on, you should see it light up. It's lighting up almost steadily because I'm getting 30 bangs a second. Let's slow that down. Let's try the other number format. We'll do the old school one. Let's say Metro 1000. That'll give me one bang every second. And, oh, see, it turned off. Why did it turn off? Even though this still has an X in it, why did it turn off? Anybody want to guess? Reason why it turned off is because I respawned the object, right? Because I changed one of the arguments in the name of the object. As soon as if you put anything in here, you click in here, you add a space and take it out and click off of it, that's respawning that object. So, and by default, that object is off. So I'll have to send it the toggle again to turn it on. Does that make sense? All right, you'll find that out. You'll find that a lot, especially if you delete a metro or you delete a jit.world, your toggle may still show that it's turned on, but it doesn't send a 1 until you actually engage with that object. So, and by default, these are off. So if I respawn it or I change its value, so now let's do one for 2000. So I'm changing the value. If I click out of it, it's now off by default, even though this toggle still says it's on, right? Because the toggle doesn't know whether this is on or off. So I'll need to send that 1 again by turning off this toggle and turning it back on, right? Again, just to remind you guys, a toggle is simply a 0 or a 1. It's a interface object. If I patch this to a message, I can see that 0 or 1. I could do the same thing. I could patch it to a integer box also. 0, 1, 0, 1, right? Cool. Okay. I'm trying to scroll with my hand. Here we go. Okay. I wanted to show you this. So if you hover over an input on an object, it will tell you a brief description of what that input is expecting or what its function is. So like a toggle input, it's going to say toggle. Int sets the toggle, bang reverses it. So I can set this toggle by sending it a 1 or a 0. If I send it a 1 and it's already toggled, it's just not going to change because it's still a 1. If I send it a 0, it'll turn it off, right? Or I can send it a bang. So if I send it a 0 and it's off already, it's not going to change. But if I send it a bang, it'll actually toggle on or off, on or off. So that hovering over that inlet tells you what that inlet wants and also how it works. Let's see, graphical hover over input, talk about arguments. Arguments. So look at this metro here, metro 2000. The 2000 here is what's called an argument. So there's a couple different ways you can interface with an object and change its settings, right? In this case, this metro has a couple different settings. And if I open the inspector by clicking on it and either clicking over here on the right where it says inspector, the inspector icon, or you command I, and that's what I mostly do, command I. It'll show you in the inspector all the different settings of this. Those settings are either attributes or arguments or messages. Those are basically your 3 ways of interfacing with an object. So this, if it's just a value without an @ symbol after the object name, that's what's called an argument. So this Metro 2000, the 2000 is an argument, and that gets populated into its interval attribute here, and it'll automatically set that attribute at 2000. Another way of interfacing with this object and changing its settings is to use attributes, which are basically the same. They just have a different syntax, and they use the at symbol. So if this, I was going to say at interval, which would be the same thing as using this argument, but I'm just showing you at interval 2000, right? I could take this out, this metro 2000 out, and say at interval 2000, and it would be the same thing, right? So that's another way you can interface with an object, either through arguments or attributes. And then the last way is by sending the object a message. And that's the way you will do it most often when you want things to change during the execution of your patch. Like the user is doing something and what they do changes the attributes of these objects so that they move around or whatever. You're usually doing that by sending it a message. And that message is going to set one of those attributes or set one of those arguments. So I believe if I'm looking at looking at the object, if I click on this object, this icon here that says reference, that'll show a quick documentation reference for this, and it'll show you what messages this object wants to receive. So if it gets a bang, it'll start the clock. If it gets an integer, if it's a 1, it will start the metro. If it's a 0, it will turn it off. And usually, if it's a 1 or a 0 and you send it like a 3, it'll still turn it on. Basically, it says anything greater than 0 is going to turn this thing on. Anything 0 or less is going to turn it off. Make sense? If you send it a float, that will be it'll interpret that as a time interval. You can send it a specific list, and that's probably going to be defined in the help file. And you can send the word clock to select a clock source. That's kind of an advanced thing. I've never really done that. Or you can send it the word stop to stop it. So those are ways you can interface through messages. So if I wanted to change this interval, I believe I can send it the message interval with a new interval, and it would change. So if it's at every 2 seconds and we want it to go much faster, I can send it interval 500, and it should go much faster. And now it's blinking faster. Does that make sense? So I've sent it a message that it understands. Yes?
Is there a reason you would do that rather than change the 2000?
Yeah, because if I wanted this metro to change based on like user input, they're not going to be able to go in here and change the code.
Right.
But I can have, if say there's a big toggle here and it goes one speed it goes at one speed when they toggle it, and a different speed when it's not toggled.
Okay.
So let's build that. That's a simple thing to build. So you have a toggle. There's an object called select. Either you can either spell it out, select, or you can just say SEL, which is what I usually do. And you put down what you want to test for, what number you want to see. So we're going to say every time there's a 1, that'll send out a bang. So I'm patching this toggle into this select 1. So if I hover over the input, you can see it says this is the value to be tested on this input. The other input on this says what value you're actually matching for. So I could change this by sending it a 5, and then it would select for 5 instead of 1. Right? This is the bang if it matches 1, or just send the input along if it doesn't match 1. So if this is going to be a 0 or a 1, we know that if it's a 1, this is going to send a bang. It'll send a 0 out of here if it's a 0. So what we can do is use what's called a trigger. Actually, we don't even need a trigger. Do we? Yeah, we do. No, we don't. We just need a button. We can just use a button here, and pass it along to here. That'll change this 0 into a bang basically, and we can have a button over here. So now it will button on that one when it's toggled. It'll button on the other one when it's untoggled, right? And now I can have 2 different interval messages here. Say interval 2000 and interval 500, and I can attach that to that and attach this to that. And now, especially, and now when I toggle this, you can see that it's going faster, and when I untoggle it, it should be going slower. Thank you. So I missed the patch cord. Buck caught it. Right? So when I toggle it, it's going slower. And when I untoggle it, it goes faster. Does that make sense? That would be a reason why you might want to use these messages rather than putting it in the object. This is an example of user interaction. We can, by the way, you can add this to presentation mode. If you go in, I believe it's under arrange, include in presentation. I usually use the Shift Command P, and it highlights it in pink. It'll highlight the object in pink, and then if you go into presentation mode, it'll only show that object. So this is how you could build a user interface where you can let them see some things and not see other things. But I'll show you that again later. All right. Okay. Done that. We did the Metro thing. We looked at I want to look at some more stuff with messages. So we looked at how we can send a message to an object to change its attributes. We were sending this interval message to a Metro object. You can also work with messages or lists and like break out pieces of them, and you'll have to do that a lot in Jitter or in Max in general, because you'll get like a list of 10 values and you want the third value, or you want all of the values but some of them to go here and some of them to go there. So we have, there's an object that you'll use a lot called Unpack, and also the pack object. These are both objects that deal with lists. So let's start with a list. Let's make a list. And a list can be composed of several different data types. It could be a list of symbols. It could be a list of ints, floats, or a mixture of everything. Let's make a mixture of everything. So we'll make a list called, where did my list go? 23, that's an int. Jitter rocks in quotations. That would be what? A symbol. Good. 2.9, what's that? That's a float. And which is just, that's a symbol also. It's just, or a list. It's a one-item list or a single symbol. You don't need to put quotations around a symbol if there's no spaces in it. Yes? Yeah, it does. I'll show you that in just a second. So we now have this list that is composed of several different data types. We can unpack that object by specifying how we want to unpack that. So I can say I want to unpack integer, symbol, and you can use I don't know how to describe them. They have abbreviations for these. I for integer, S for symbol, F for float. So I, S, F for float, and then I believe I just say S again, right? For that one at the end. And if I unpack this, I can get those individual values. Go ahead and patch a couple of messages. And make sure you're patching to the right inlets of these messages. And so now if I click on this, and again, when I'm clicking on objects, you either have to lock your patch by going down here and clicking the lock icon, and then you can click on messages. Or you can lock your patch by command clicking on a blank area of the patcher. Or you can just leave it unlocked and hold down the command key and then click on the object, which is what I usually do instead of locking and unlocking my patch. All right. So now you can see I was able to break these out into the individual values, and now I can send these wherever I want in my patch. So that's unpack, and that's one way of doing unpack. Another way, a lot of times you're just working with number streams in unpack, and so you can also just unpack and set initial values. So I can say I have like a number stream that has 5 values. I can say unpack 0, 0, 0, 0, 0, and it will put zeros in there as placeholders, but we'll replace those with whatever comes in the number stream. So let's make a little number stream here. 13, 12, 40, just make like 5 different numbers, integers. And I can do the same thing here. I won't do it on all of them. We'll just do it on a couple of them. Here, if I just want the first 2 numbers out of that number sequence, I can get to them that way, right? I could also, instead of unpack, say I only wanted the first 2 numbers, I could just unpack just those numbers. So I'm sending it the same multi-item list, and I'm just unpacking the first 2 items from that list, 12 and 34. But if I wanted the last 2 items, I would have to probably, I'd probably have to do this unpack and do all 5 numbers, but then just attach to just the last 2. Does that make sense? Like this. Now I can get the last 2 numbers. There are some other ways you can split up lists using the ZL objects, but we'll get into those later. Unpack is the main way you use it. Yeah?
How do you write notes? Like around
comments. So you hit the C key, and then you can write notes. Yeah. So yeah, you use the C key to make comments. You definitely want to be commenting your code as much as you can to help you understand and to help me understand when you turn it into me. All right, pack. So we looked at unpack. Now let's look at pack. So pack can be used to create one of these like multi-item lists out of a bunch of single numbers. So pack, let's start with just a number stream first. Pack 0, 0, let's just do 3 items. Now, pack has an interesting way that it works. It will only output its values when something changes in the first inlet, but not the other 2 inlets. Let's add some integer boxes. Just hit the I key. Make 3 of them. Then I'm going to patch those into the 3 inlets on the pack object. Now, if I change this first one, you can see it creates that 3-item list and it outputs it. But if I change any of the other 2, it doesn't output the list until I change the first one. Does that make sense? Why would you want it to do that? Well, because you might have a bunch of values coming in at different times, but you want to send them out in a group. So if you just arrange your patch to make sure that this is the last value that comes in, that's an easy way of grouping those values together and sending them out as a list. There are other ways you can group values, and there are other objects that we'll look later at, but this is one of the easiest ways. So that's one way. But what if you want it to output its value if any of these values change? Well, you could do something like this, where you could have a trigger, whoops, not a toggle. You could have a button, or not a B, a button, or you could have a trigger bang, which is the same as a button, coming off of these, and every time these values come in, it sends a bang to this first one. But that would be kind of clunky way of doing it. The easier way is to use a slightly different object, and that is called a POC instead of a pack. And it's just pack without a C. P-A-K. And to distinguish it, we pronounce that POC. So POC 0, 0, 0. Now, and go ahead and just, actually here, instead of having to draw all this stuff, let's highlight this and option drag, hold down the option key and drag it, and then you can duplicate it that way. And now I can change this object from a pack to a POC by taking out this C. And now if any of these move, if any of these change, it outputs that number string. You'll use these a lot. Pack and POC. You can also pack lists of non-numbers. I won't spend too much time. I'll just show you that real quick. So pack or POC. Let's do an integer, a float, and a symbol. Send this to the right inlet of a message. And let's see, what is integer? So let's give ourselves an integer 3, a float 3.14, and a symbol pi. So if I click pi first, it sends out 0, 0.0, and pi. Why do you think it did that? Well, because those were the initial values that were set in that pack object, because it didn't get anything input to it yet. And initially, it's going to set an integer as 0 and a float as 0, right? But if I click on these, it'll send those out with the new values. So that's pack and POC, and they're useful for creating lists. Let's see, in my comments here, let's see. Working with lists. Here, I'll move this stuff down. You can draw boxes around things to move them around. Okay, working with lists. Let's see. Prepend and append. So say I need to use these, say I have this list of 3 numbers, and I want to use that to create a scale message to change the scale of an OpenGL object, right? And the scale on OpenGL is going to be X, Y, and Z, 3 values. So let's you can do that in a couple different ways, and let me show you that. Let's create a let's just duplicate this POC over here. Command D or Option drag it, and actually change the zeros here to floats. And then also, which was something I think they added in like Max 7.2, is you can actually change these integers to floats through the inspector by changing their attributes. So if I select those and I open inspector and I change and I go down to, I know it's here somewhere. Decimal, oh, here it is, format at the very top, decimal integer. I can change that to decimal floating point, and now they're float boxes. All right. So I want to turn this into a scale message. So I have these 3 numbers. That's great, but I need, in order to send the right message to the OpenGL object, I need the word scale and then those 3 numbers. So does anybody have an idea of something I could do to add the word scale in here? Yes?
Well, you could use the pack in this. You can maybe use 2 packs, like do a pack. Just do a message with the scale, and then have that going with one end of a new pack message, and then have this pack message going together.
Yeah, that could work. So she's talking about just packing the word scale in the list. She was talking about using 2 nested packs, which would work. It wouldn't be necessary. You could actually just add it to this pack. I could say pack scale and then the 3 numbers. And now it gives me, oh, I need to shift these over, right? Because the first thing it's the first element in the list. It's going to get replaced by this 7.9, so that doesn't help me any. So shift all of these over 1. And respawn this object so that it re-puts the word scale as the initial value there. And now if any of these change, you get the word scale and then the 3 numbers. And that's a really common way of doing a scale, to compose a scale message or whatever 3 value message you need. It may be a position message, a rotate XYZ message, or something like that. You can pack or POC so that you don't have to change the first input. POC, the word that you want to have POC'd in there, and then the 3 values. The other thing you can do is use a prepend or an append object. And what that does is it adds a parameter, or it adds an element to a list either before that list or after that list. So if we have our POC scale, so let's see. This is compose scale message. Let's duplicate this. And this time, take out the word scale. Just say POC 000. And that's going to disconnect one of your lines, so you'll have to move these over again. Make sure all 3 numbers are connected. All right, so now we have, whoops. If I change any of these, now I just have my number stream, right? I can use a prepend object, and I can prepend whatever I want, and I'm going to prepend the word scale. And I pass it through that first. Now I get I get the same message. Why would you use one or the over the other? Usually it's just style, but there are certain times where one is necessary because you can't unpack it or some other reason. You will have to use prepends and appends on occasion. So prepend puts the value before the list. If I used the object append, so say this was, instead of a scale message, now it's like a color message, and we wanted the fourth value, say, is the alpha channel, and we want everything to be alpha of 0.5. I can have this value and prepend the word color, and then append the word, or append the value 0.5, and it should create now a 4-element list where the fourth element is always 0.5, right? But that append, I can put whatever I want here, depending on what kind of message I'm trying to compose. So I could put hello, and it would put the word hello after that. Not that that would be any use to me, but maybe it is if you're creating a a message for text or something, right? Okay, so that's prepend and append. You have it on the right. You need to put on the right inlet of that message. Oh, delete that. So go to the other inlet of the message. Coming out of the prepend, okay. Go to the right inlet of the message. Whoops. Just select that and delete it. Whoops. Make sure you actually click on it. There you go. And right inlet. There you go. Now try it out. It should work. There you go. Yeah. Okay. So that's prepend and append. Let's see, how much more do I want to do before we break into the fun patch? Oh, I definitely want to do this. Order of operations. So, we talked about how you can use a pack object instead of a POC, so that only this first inlet value triggers the list. And say you do that because of these other values in your pack are coming in at different times, and you want everything to be gathered into one list and then output. How can you make sure that this one here comes in last? Well, you can do that either by structuring your patch through order of operations, or by setting an explicit order of operations by using a trigger or some other method, and I'll show you those. So by default, the way Max works, and it's really counterintuitive, and I don't know why they chose it to do this way, but the order of operations goes from right to left and bottom to top, meaning where the objects are graphically located in your patcher will go from right to left and bottom to top. So let me see. How do we demonstrate this? Oh, I know what. A button. And now let's do 3 values here. Let's say 1, 2, and a 3. And a integer box patch all of these into the integer box. Sorry, the number box, I guess. Just hit the I key. And now patch this button into the left inlets on all of these messages. So ostensibly, this button should send the bang to all of them at the same time, you would think. But computers don't do things all at the same time. They have to do things one at a time. So it does from right to left and bottom to top. So it goes the 3 first, then it puts a 2 into the box, and then finally a 1 into the box. So the last one we end up seeing is a 1. There was a 3 and a 2 there for a split second. It probably never even drew it on the screen. If you recorded it and went frame by frame, you probably never see it. But it did happen in the event queue of the computer. It did happen, right? Try rearranging these. Now go ahead and take this 3 and put it up higher than the other 2. And put it to the right. Now it's the 3, as you can see, right? So that's how the right to left works. Let me see if I can show how the bottom to top works. Okay, so put these vertically, stack these vertically. And which one do we end up with? I end up with the 3 because it was the last one, because it's going from bottom to top. So it goes first from right to left, I believe, and then from bottom to top. So it should put the 3 in here, but if I also at the same vertical level now put a 4, and this 4 is left of this 3, I think it'll end up with the 4 in there, right? And if I put this 4 on the other side of the 3, it should end up with the 3 in there. But it doesn't. It goes the 1. Why? Bottom to top, right to left. You're right. So it does bottom to top first and then right to left. So it went right to left first. So first it went a 4, then it went a 3, then it's further to the left, and then it goes from the bottom first, so then a 2, and then finally ends up with a 1, and that's why we had a 1 in the box. So it's confusing as all hell, and don't program this way. Just set your own order, because this is annoying, and you have to like end up moving buttons around, and the values are hard to predict, and I hate it. But they had to set some rule, and that was the rule they chose. So instead, I can create an explicit order by using triggers. I can say trigger bang, 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 and that will give me 4 bangs in a row, and those will come out of each of these outlets. And if you hover over the outlet, it says what order it's going to come out. So the furthest to the right, because things go from right to left, furthest to the right is going to be the first bang that comes out, and the furthest to the left is going to be the last bang that comes out. So now I could set my order this way, 2, 3, 4, and if I want, say, 4 to be the last one that goes in here, I can put that and set that order explicitly with a trigger. Now 4 will always be the last value no matter where it is on the screen. If I move this way over here, it's still the 4 because I have set that order explicitly. Okay? You can either trigger a bunch of bangs like this. Another thing you could do is just trigger those values. You can trigger anything. Trigger 1, 2, 3, 4. And it will send a 4 out this outlet first, and it'll send a 1 out this outlet last. Always it's going to send things out from right to left. But you can actually trigger anything. You can anything. And you can use a trigger to convert one type of thing to another type of thing that don't normally. So if I have like a float and I want this float to anything coming into the float makes the word anything, I could do that. Whoops, right inlet on this message. And it's only going to ever put out the word anything. That's another way of using trigger, but that has nothing to do with setting an order. Just wanted to show you that. Okay. Cool. I think we'll save the starting making the slot machine for next week. And I think we're going to shift gears for the rest of the class and build this. Cool. So go ahead and just save this as. Actually, I guess it's still data type. Well, save this as and call this lists. We probably should have made a new patch, but that's all right. Lists in order of operations. Lists in order. Or you could just call it class 2. I don't care. All right, great. All right, we're going to make a new patch now. We're going to make this. Let me show you this patch. This is, where did it go? Here we go. This is something I made because this morning, if you got up at 4 in the morning, you would have seen the super blue moon eclipse. Super blue blood moon. And so this is a way of this is a patch that creates the super blue moon eclipse. And you can click on the screen and the eclipse will eclipse over the moon. All right. So the first thing we're going to need, we're going to build this from scratch. So new patcher. So the first thing we're going to need is a jit.world to make an OpenGL context to display everything. Let's give it a name. Call it moon or eclipse. I'm just going to call it moon. Okay, we'll need a toggle to be able to turn this on. And if I turn this on, the color should turn from black to gray because that's the default erase color. It's to show you that it's working. Okay, now we need a picture of the moon. So let's go grab a picture of the moon. Go to Google and put in moon and go to images. And let's pick one with transparency. So go to tools here and choose color transparent. And I think this moon's fine. This one here, this first one, 1000 by 750. Choose that one. If you click on it and then go to view image, you should be able to get just the file. And now you can save this. If you have just the file open and you save page as, you should be able to, under format, make sure it says portable networks graphic image or PNG. And we can call this moon. And where you want to save it is in your documents, max 7. And then you can create a new folder in there if you want. Anywhere in the max 7 folder will be fine, or in a subfolder of there. I created a subfolder called user media, and I saved it there. Okay? So does anybody have problems downloading the moon?
I can say it's a purple bracket.
Okay. You have Slack, right?
No.
You do not have Slack. Let's see. I can upload this to the website real quick. I don't know. I don't know. Let's see. I should have just done this before class, but I decided to do this in the last like 20 minutes before class started. Download documents, max 7. Come on, hello, user media moon. Okay, if you couldn't download it for whatever reason, go to the class website and under week 1, I put it Moon PNG. Should be able to download it from here. Just use the download button. Do I have to save this maybe? All right. Okay, so once you've done that and you put it in your Max 7, you should be able to find it in Max by going to your images here and searching for Moon. And there it is. It'll pop up and it should just be the moon without a black background or something. That's showing that it has a transparent background. You can drag this right into your patcher and you'll get the little moon icon, which this is useful for putting pictures in your patcher as like user interface elements, but you can also get the matrix out of this for actually displaying on the screen. So if I send this a bang by using a button, it'll output its matrix. I can send that either into the jit.world and that'll put it on the jit.world video plane. Where's my... You can't find it? Did you put it in your Max directory and it couldn't find it? All right. You can... Here, try this. Yeah, you can just drag it from your desktop. Yeah, from your... yeah, do that. Find it in your Finder and just drag it in there. Let me show you that. Yeah, well, you guys. So yeah, just drag it from your Finder if it didn't find for whatever reason. Okay, so you can just patch that right into your jit.world, and if you bang this matrix, it will put it into the built-in video plane and give you a moon. But what we want to do is actually have a little video plane that that's easier to control. So we're going to create our own video plane. So the video planes in Jitter are called JitGL.videoplane. As soon as I do that, it puts it on top of the old video plane, which is why the moon disappeared. So I can take this out of that video plane and put it into this video plane and bang the matrix again, and now I got the moon again. But what the heck, it looks weird. Why do you suppose that is? Well, because the video plane is being stretched. Because the video plane is a default size, and the image is getting stretched to that size, and that default size looks to be kind of 1 by 1, I think, right? But the image is not a 1 by 1 image. So you can, there's a couple ways you can deal with that. Questions? Yes?
Yes, sorry, my moon is not showing that. Oh, wait, no.
Just drag it from your, do you have it in Finder?
Oh, no, I have it. I have it on my patch. It's just when I press the button, it's not appearing.
In your JIT video plane? What's it say in your Max window? Command M to open your Max window. Do you have an error?
It says it's not a valid attribute argument.
So what is?
Oh, sorry, that's from a different. That's from a different.
That has nothing to do with it. Okay, because your jit.world isn't turned on. You have to make sure your jit.world is turned on. So put an X in the toggle going into your jit.world. See this? And if there's already an X, then turn it off and turn it back on again.
Oh, okay, got it.
Okay? So we've created our own video plane here. But as you can see, it has a black background. We know that this has an alpha channel, so we have to set this up for being able to have an alpha blend. So we need to blend enable it. So we have to set the attribute at blend enable 1. Okay, now it lost its matrix, so I'll have to bang this matrix into it again. And oh, so now I see two moons on top of each other. That was because of this jit.world. The video plane still has that moon that we sent it a while back. Let's respawn the jit.world to get rid of that. So just put a space in your jit.world and then take it out and click out of it. Then you'll have to turn it back on again, remember? Now I just have the one moon. Yes, questions? Just drag it from your, you're on Windows. Yay! Try this. Did it give you an error that says it can't read it or for some reason? So try this. Take a message that says read and patch that into the empty box. That should open up a file document, dialog box, and then you can select the file out of that. If it still doesn't work, then that's some problem with PNGs in Windows, and I'm not exactly sure how to solve that right now. Okay. So we got our blend enable one now. Our moon is kind of distorted. There's different ways we could handle this. We could, there's a thing called transform reset, which will automatically squish the image to fit the window and maintain its aspect ratio. I don't think we're going to do that because I needed to be able to independently control it. So I figured out some good scaling for this image, and I believe the scale is at scale 0.25 and 0.18. Oh, I said scalar. Sorry, I do that. Scale 0.25, 0.18. And now if I send this button again, now we get a moon about the right aspect ratio. It's a little stretched. I think it's not as stretched when I go full screen. Right. Okay, so we got the moon. Now, we're going to make this moon, because it's a super blue moon, let's make it a little bit blue. Not that a blue moon is actually blue, but just for fun. And to show you how this works. A video plane, you can actually give it a color message, and it will colorize the content that's displayed. And you can think of the color of the video plane like the color of a projection screen. So if you had a yellow projection screen and you projected a color image on it, you'd still see that color image. It's just like everything that was white would be really yellowy, right? So it kind of colorizes it without completely taking out the color channels. So we're going to take out a little bit of red, actually. So we're going to put this color as 0.75 in the red channel, 1 in the green channel, 1 in the blue channel, and 1 in the alpha channel. And now if we bang this matrix again, it's a slightly blue moon. Still with me, everybody? So now, yeah, I got to bang the matrix again with this button up here. What we could do actually is this second outlet of this jit.world, you can see it says render draw bang. You can just attach that to this button, and now it'll be constantly sending this matrix. So if we make changes, it should come straight back. Okay, so we got that. Now what we're going to need to do is, well, first of all, this space looks weird, right? We want space to be black around the moon, or the night sky anyway, to be black around the moon. So we need this jit.world to have a black background. By default, it's gray, and that's so that you can tell whether your jit.world is on or not. But you can change the background by changing an attribute called erase color. Because the way a video engine works is it draws out a frame, puts it on the screen, and then it erases that frame, and then it draws the next frame. And what you erase that with can be whatever color you want. Usually it's black. Sometimes it's white. You can make it yellow or green. If you want a green screen, making the erase color green, that's an easy way of making a chroma key that'll have whatever your objects are in the foreground and the background's bright green. But in this case, we want it to be black. So you can either hover over this inlet and right-click to create an attrui by picking erase color out of this list, or I can hit the A key to give me an attrui object and attach it to it, the jit.world, and then going in here and choosing erase color out of the list. And now click on this color over on the right-hand side, and then over here, change the slider value from gray to black. And now we have the moon in a black sky. Yes, question.
I'm just not able to do erase on this one. It's not.
Did you make an attrui object?
Yeah, I made an tree object. I just can't. Like, I don't know. Maybe it's not.
Do you have your attrui object attached to your jit.world? If it's not attached, it won't work. There you go.
Okay.
Now try it. Go to erase color.
I can't even. Yeah, I can't go to erase color. It's just not.
So click on it.
Yeah.
Click lock your patcher or hold down command. Click on it. Go to erase color. Yeah. So again, when you're interfacing with user interfaceable objects, you have to be your patcher either has to be locked or you have to hold down the command key. Oh, here, let me. What is it? Mouse pose. I forgot to run this. If I run this little app, you guys will see when I am holding down the command key. All right, so now you can see when I hold down the command key. All right, so now we have the moon in a black sky, right? And so now we need to make an object that eclipses this moon, right? So I think the easiest thing to do is just create a circle grid shape and make it about the right size, same size as the moon. Let's start with that. So let's make a JIT GL grid shape. And I think by default, the grid shape is a sphere. It looks like a huge circle, but that's because it has no lighting enabled. And so when you have a flat shaded sphere, it looks like a circle. We want to change this. We're going to change this with an attribute at shape. And then we're going to make this a circle. If I click out of that, it gets a little bit smaller, but it looks essentially the same. But now it's a two-dimensional circle instead of a three-dimensional sphere. Now we need to change the scale of this to match the moon. And let's see, let's try 0.25 first. At scale, 0.25, 0.25. That is a little bit big, right? Let's see. We can turn this on and off to see what's underneath it by making an enable message. Make a message that says enable. And then a wildcard $1. I think somebody earlier asked about how you can use a variable. This is in a message. This is a way of using a variable. Oh yeah, so we used the pack before. This was another way of creating a message. You can use a wildcard variable. So I could have just said pack enable and then 1 and then had it in there. But it's easier just to make this one the message. So yeah, if I have this enable 1, a $1, this $1 gets replaced by whatever is coming out of this toggle. So if I enable 1, that means it's enabled. Enable 0, that means it's disabled. And now you can see what's underneath it. So it's a little bit big. Let's make it a little smaller. I think 0.18 was about right. Yeah, it's a little bit bigger, but you actually want the shadow of the Earth to be a little bit bigger than the moon. All right, so now we have this. We want this shadow to be black. So let's change its color. At color, 0, 0, 0. And I believe the fourth one is the alpha. So if I had this be an alpha of 0.5, it should be half alpha, but you don't see anything under it. Why? Because by default, blending is turned off. So we have to enable blending. I see how up here we had at blend enable 1. We didn't do this on this grid shape, so we got to add the blend enable. At blend enable, and again, it's a lot easier instead of typing these out, because you're really likely to make a typo, is to start to type it out and then select it from the list. Blend enable 1. Where did it go? Well, now I don't see it. I don't see the moon. Oh, I do if I disable it. All right, so it's still not. I must have the order of the colors wrong. So maybe it's alpha first. There's two different ways that that colors are described in Max. It's either the alpha first or the alpha last, and they're not consistent. It depends on the object, unfortunately. Let's try 0.5, 0, 0, 0. Actually, I can look at my notes here. Nope, that didn't work either. All right, make them all 0.5. So we actually are going to have a gray moon. There we go. But I still don't see the thing underneath it. That's might be the blend mode. Or so making a Trui object and attach it to the grid shape here. And let's see. Whoops, I better move my patch up. Here we go. And go to blend, alpha blend. I think instead of alpha blend, let's do multiply. And then it will multiply whatever's underneath it by the value. Why? That should work, and it's not. Why? What did I do wrong? Depth layer. Might be layer issue. Blend enable, blend multiply. Okay. Okay, so it must be a layering issue. So which object in OpenGL is on top when you have layers is usually specified by the Z value. So if something is closer to you, has a higher Z positional value, it'll be a higher layer than something further away from you. That's the default behavior. We're working in a two-dimensional thing right now, and all the Z values are the same, and so it's kind of a crapshoot as to which one is on top. So to get away from that, you actually have to disable depth sorting. And so you do that by saying at depth enable 0, depth enable 0. And again, this is kind of confusing now, and put this on both of them. At depth enable 0. It's kind of confusing now, but I'm gonna be back. There we go. I'm gonna be backfilling the information on how each of these work more. We'll be looking at these attributes on an ongoing basis. All right, so now we can actually specify a particular layer, right? So we want at layer. So I'm on the moon object right now, the video plane. We're going to have that as layer 0. Okay, and now at depth enable, and this one is going to be at layer 1. So now we'll put the grid shape on top of the moon. There we go. All right, so let's change this. I believe instead of, I think one of these should be 1. I think we want the alpha to actually be 1 in this case. Maybe not. Oh, because it got changed back to alpha blend. Change this blend back to multiply. There, I think that got a lot darker now, right? 0.5. What happens if it's 0.5? Oh, so let's just put this alpha blend in here, because every time I change an attribute, it goes back to the default of alpha blend, and we want it to be multiply. So let's put it in here under the attributes. At blend multiply. There we go. So now we have this, and we have it making the moon darker. And if I change its position, say, so if I change this a truey from blend to position, and I move it, I can have an eclipse that kind of occurs laterally, which isn't really the way eclipse works in real life, but you can see how this is kind of working. If I'm moving this X position, I'm able to make this eclipse slide across the moon, right? But we want actually is to make it rotate across the moon, right? So what we can do to make it rotate across the moon is basically we make the object rotate by sending a rotate XYZ, but we need to change the center point of where it rotates. And that's called an anchor. So by default, the anchor for a rotation is the middle of the object. So if I send a rotate XYZ and I want it to spin like this, so I'm spinning it around the Z axis. So I send rotate XYZ 0, 0, and then a float between 0 and 360 to make it spin around. It's going to want to spin right from the center of the object. But I can pin that anchor point down below the object, and then it will spin like this, which is what we want. We want it to kind of rise and set like a sun. So let's just do this in a simple manner. We are going to change we're going to add an attribute to the end of this list. And the attribute is at anchor 0 period. This is going to be 3 floats. And we want it to actually, we're going to anchor it up 1. Anchor 0, 1 period, 0 period. And so now the anchor point for this is actually down here. You'd think it'd be up here, but actually Y values in OpenGL go from the top of the screen down to the bottom. So 1 is at the bottom and 0 is at the top, right? So now it's anchored down here. So this thing is sitting down here. We're not seeing it because it's a black multiplied against black. If I change this erase color to gray, you should probably see it down here somewhere. Come on now. Maybe not because of the multiply. All right, never mind. It's down there. It's just there's nothing that it's being multiplied with right now. Okay. Now if I set its position, so I'm anchoring it at 0, 1, 0, and then I set its position at position -1 or 0, -1, 0, 0 period, -1 period, 0 period, because these are floats. Then it's back on top of the moon, right? But now it's anchored down here. So if I rotate, it should rotate in the way that we'd expect. Go ahead and change your truey back to rotate XYZ and change the rotate Z parameter. And you can see that rotates into the moon and rotates out of the moon. My frame rate's starting to really drop, but that's because I'm screen recording. Okay? Is that working for everybody? You want rotate XYZ because it's the easier one to work with because it just rotates 3 different Euler angles. Otherwise, you have to define a center point and then how much rotation around that center point. Great. So we're going to create an animation now that makes this value go from the minimum point where just before you see it on the moon, which is what, 20, maybe, oh, a little bit more than 20. Let's say 21. From 21 to probably what, negative 21? Yeah. So if we have an if we make a number that slides in value between 21 and negative 21, then we can make this automatically rotate across the moon. So to make an animated number stream, one of the easiest objects to work with to do that is called the line object. Line. It says generate a timed ramp. It creates a ramped value that by default the ramp is just linear. It'll just slide from one value to the other, but you can actually set like easing in and easing out so that it actually like accelerates and then slows down at the end of the ramp. This we're just going to use it in its standard form. So by default, line wants to work with integers, but it will work with floats as well. You just have to give it an initial number that's a float in order for it to be set up for floats. So actually, we wanted this to go from 21 to negative 21. So let's say line 21 period. That should set it up for an initial value of 21 and also set it up for floats. Attach this. Actually, no, don't attach it to anything yet. Now, to actually make it work, we can go into the help file for line by option clicking on the object, and then it shows you kind of the syntax that it wants. If you send it a single number, it will jump directly to that number. If you send it a list of 2 numbers, it will go from whatever number it's on currently to whatever number is to whatever number you give it, and then it'll take that many X number of milliseconds as the second value in the list that you sent it, right? If you send it 3 numbers, but the first one is separated by a comma, it'll first jump to 50, then it will go to 150 over 1 second in this case, right? So this is the common syntax, the way that we do it. We first send it the number we want it to start at, then a comma, and then where we want it to go and how long it takes to get there. You don't necessarily need to do that. You can just send it a 2-number list or a single number. But if you send it a single number, it'll just hop directly to that single number. If you send it a 2-number list, you don't necessarily know what the starting number is. It'll be whatever the last number was, right? So we want it to go from 21 to negative 21 in like, I don't know, 4 or 5 seconds. So let's create this list. 21 period, comma, negative 21 period, space. Only use the comma once. And then how many seconds, milliseconds, to take? And let's have it take 4 seconds, so 4,000 milliseconds. Okay?
Is this going to be uploaded online?
Yes. Yeah. And then, all right, so now let's take a look at what the value that this is creating. Make a new message and patch this to the right inlet of this message. And go ahead and command click on this, and you should see a number stream that it creates for you. Right? So now we can take this number stream, and we need to use our wildcard, like this enable $1, to create a rotate XYZ message. What do you think the format of that message is going to be as I'm setting it up? I'm going to end up using a $1 in here. Does anybody want to take a crack at it? No? Okay. So it's going to be this message, rotate XYZ. And if you start typing it and you're close to an object, it will automatically populate it for you based on what nearby objects are expecting. Then we're going to not rotate in the x-axis, so we're just going to leave that as 0. We're not going to rotate in the y-axis, so we'll leave that as 0. But we are in the z, so we're going to put a $1, and that's the actual wildcard. So this will create a message, rotate x, y, z, 0, 0, and then the number that's sliding around, right? So if we patch that to our grid shape, we should now be able to actually make this animate across the moon. And if my frame rate was better, you would see that. Maybe if I go full screen, it will be better. Okay. Is that working for everybody? You want me to take a couple minutes and look at problems? All right. Who has problems? Okay, what do you got? So are you just behind, or is it not working?
It's not working.
Okay, so that's enabled. Make sure that's enabled. Did you see 21 to negative 21 over 4 seconds? Looks right. Color 0.5. That should work. Was it working before you sent it?
Everything was fine until we did
the rotate?
the rotate.
Okay, so just respawn the object first of all. Just by putting a character and taking it back out. And click off of it. And do you see it up here? Is it blending with it? Yes, it is. Okay, so now just try moving that third one just by hand, just a little bit, and seeing if that's going to work. Okay, so it should work. So then that means that there must be a problem with your message. Check your message. Did you spell something wrong there? No, try making a new one. All right, actually, make a blank message and pass the line output directly into the right inlet of that new message.
This line output?
Sorry, the line from the line 21 to the right inlet of that message, and then the other message, the new one you just wrote. You can leave it attached to that. Okay, and go ahead and activate this again, and let's make sure that we actually, no, this right here. The 21, 21, 4000 message. Yeah, activate that. No, you didn't activate it. You gotta, yeah. But what I wanted to do, oh, it's working fine. Okay. I don't know what you did wrong, but it's working now.
Thank you.
Anybody else want me to look? Okay, yeah.
It's probably the same, whatever it was.
So what's going on? It's not animating, the line isn't running. So sometimes the lines get broken. Try just respawning your line object. Put a character in there, and then, yeah, click out of it. Try it again. I'm sorry, go ahead and activate the message now. See if it works. The 2121. Yes. So sometimes the line object will crash. It has like a built-in metronome that sometimes crashes. So if it's not working, try just deleting your line object and then undoing and then selecting that message again. Did that fix yours, Anna? You're on the wrong inlet of your line. I heard you end up with different values.
I was just introducing this.
That's cool, whatever. You got it perfect.
This is 70. I need mine to
Oh, actually, okay. So is that animating now? Try it. Can you click on that?
And this is stop moving.
Okay, so you also, wait.
This is wrong. Oh, I put this in the wrong one. That's
Yeah, but that's not going to pass that along. You make sure to go directly from your line to that rotated tab. Okay, you're rotating the wrong thing. You're rotating the moon. Your moon is spinning around.
That's cool.
Anybody else want me to, anybody else? Problems? Okay.
I respawned my line on that.
Okay. Wait, well, you're not enabled. Make sure that's it. Click on this. There we go.
Oh, okay.
Let's see, go ahead and click this again.
This.
Yeah. No, the 2121. There you go.
Oh,
You're
okay,
good.
great.
All right, cool. So I think we're okay? Yes?
Yes.
Great. All right, we have about 5 minutes. Let's put the finishing touches on this. We just want some text on here saying what this is. So there's an object called JIT GL text. Let's go ahead and to save some time, just copy along on these attributes. We're going to set the font size big. So at font size, and you can click it out of the list, 40. And at color, because by default it's gray, we want it to be white. At color 1111. At align, text alignment mode 1, that will do center. By default it's 0, which is to the left justified. And then let's set a position value to put it up at the top of the screen. At position 0 period 0.5 0 period. Oh, positive 0.5? Yeah. Sometimes the coordinate systems are different. This one, I believe, 0.5 will put it up at the top because it works as a 0, 0 being, I think this one is not the backwards coordinate system. Oh, we don't see anything yet because we haven't told it what text to display, right? So we need to give it the text, and super, what did you call it? Super blue blood moon. I think you can do it as a list like this without, or you can put symbol quotations around it. Yeah, great. Super blue blood moon. Okay, and what we're going to do is we're going to make just clicking on the screen anywhere activate this. So let's add some text that says click anywhere to see the eclipse. So just duplicate this, change the position from 0.5 to negative 0.5, and change the font size from 40 to like 20, and change the text to click anywhere. Okay. So what we're going to do is, built into the jit.world, if you click on your screen and you hit escape, it'll make your screen full screen. We're going to make it so that if you click on the screen, it'll make that animation happen. All right. How do we do that? Well, built into the jit.world also is the mouse interface, and it'll come out of the dump out, this last outlet of this. If I hook a message into this, nothing comes out of it by default, but if I click on the screen and I actually click, it'll say mouse and then the coordinates of the mouse and then a 1 or a 0 depending on whether the mouse is clicked or not. You can see that 0, 1, 0, 1, 0, 1. So what we can do is we can use an object called route, which is going to route data based on an input. Darn it, come on, my frame rate is driving me crazy. Route mouse. So this will both take out the word mouse, but also only give me data that followed the word mouse. Those are the two reasons why you might use route. You either use it to remove a word or you use it to actually route data. So now that I have route mouse, now I get just that number stream without the word mouse. And so now how could I get the third value from this 7-value list? Exactly, unpack. So let's unpack. We don't need to unpack all of the values. We just need to unpack 3 of them and take the third. Unpack 0, 0, 0. So attach that to the route mouse. And this third value now, if I attach that to a message, if I click here, it should be a 1 or a 0, 1 or a 0, 1 or a 0. See that? Okay. So let me just give myself some more some more room. I'm going to move this down. Move these down. Oh, we're out of time. We're so close. We are so close. If you have to go, that's fine. We only have like a minute left, I swear. All right, so we have the mouse. Click. That's a 1. All we need now is to use a cell 1. So when you click, it'll send a bang when a 1 comes in here. We can send this bang to this message here. And now when I click, come on, Moon, where'd you go? There we go. It took me a while. My computer's just really slowing down. It animates, kind of. My frame rate is terrible. All right? Yes. Let me go back to the patch. All right, so this is what we did over here. We routed mouse, then we unpacked, and we grabbed the third value from that, and then we did a cell 1, select 1. And then, so that sends a bang when it gets a 1, and then bangs this message that we send into our line object to create that number stream to make it move. Programming is kind of like a Rube Goldberg machine where you have like multiple little steps where like this does this and knocks this thing over that makes this thing move. All right, for the rest of the time, all right, so homework, oh boy. Homework is use the system that we already did with this clicking on the screen to make something else move in OpenGL. It doesn't need to have an offset like we did here. It doesn't need to have a weird anchor point. Just having a user interaction make a number stream make something rotate or make something move across the screen. That's your homework. I'll put that in the email as well. All right. Troubleshooting. Let me stop my recording.